Okay, so last time we end up with this derivation of the Hamilton's equation, Hamilton's canonical equation, and we have two. Iluha, um, oops, my board. We have in terms of partial derivative of the h in terms of p, and partial derivative of h in terms of the coordinate q, no? So depende lang kung pila ka generalized coordinates ang nasa to ang system, like for example in 3 dimension, so na ko'y px, py, pz, na ko'y x, y, and z nga coordinates, no? So this is the Hamilton's equation, canonical equation of motion. Okay? So let's have an example on how to use this um, nakahatag ba ko example last time? Kalimot na ko. Dugay-dugay na po ito, no? Nakahatag ko example last time? Wala. Or diri na tataman sa derivation niya? Murag wala, no?
Kalimot tubod mo siya.
Nakalimot na mo. Sige, murag wala, no? Say for example, one good example is this harmonic oscillator, no? So na ko harmonic oscillator. So we know that the equation of motion for harmonic oscillator is given by this, right? Mx double dot plus kx equal to 0. Using Euler-Lagrange equation, makuha na to actually ang expression, ang equation of motion ni harmonic oscillator. But using Hamilton's equation, dapat same lang sa answer, no? Using Hamilton's equation, how we're going to find or to um, express, to determine the equation of motion. Let's start with the first step is you will need to express, or you will need to determine what is the expression of my Hamilton's, okay, Hamiltonian function. So in this case, we know that L is equal to 1 half K. We know that in terms of Lagrangian, for harmonic oscillator, it is equal to 1 half mx dot square minus 1 half kx square, right? Instead of using L, we will use Hamiltonian function, which is just equal to t plus v, and this is equal to 1 half mx dot square plus 1 half kx square. But we have to take note, h must be a function of the momentum. I call this one as px, and the position x. Okay, px because take note, this is only a one-dimensional harmonic oscillator. So do na lang ko isa ka momentum, which is momentum along x. Okay, so I call that one as px. Or pwede ra ko magamit og p kay wala nang ko laing variable, no? Wala ko laing variable. So I can use h px. Okay? P and then the coordinate position x. Pero later, kung nakoy for example in 3 dimension nga motion, then I will denote the momentum along x as px, nakoy py, and then nakoy pz. In this case, one dimension lang, so you can just let your momentum as p. Okay. So you must express the sa tawag ni the Hamiltonian not in terms of the velocity but in terms of momentum. So how are we going to solve the how are we going to express Hamiltonian in terms of p and x? Dali lang, no? P is equal to, take note, p is equal to m times v. Okay? M times v. And we have what do you call that? The partial, ano? So, nakoy nga, no? I have this, if I rewrite this as m um, x mx dot is your mv, no? So you can write this as mx dot. Okay, so if I put it as mx double dot quantity square, na sobra nga m sa pika sa denominator, no? So you can rearrange, or you can simplify, or you can rearrange the 1 half mx dot square into this one, right? Na ko yung 1 half mx dot quantity square over m, okay? Such that, na po ko yung plus 1 half kx square, no? Such that the mx dot is your p, so you can actually write this Hamiltonian function equal to p over 2m plus 1 half kx squared. Okay? So the Hamiltonian now is now in terms of momentum and position. H is equal to p over 2m plus 1 half kx squared. So it is a function of momentum and position x. Now, we will now use the Hamilton's equation of motion. Hamilton's equation of motion. Duham kabok, no? Equation of motion na ako'y partial of h with respect to p. Okay, in this case, this is in terms of momentum p. It is equal to x dot. Okay, qi dot is x dot. Okay, this is equal to x dot, and partial h with respect to x is equal to minus p dot. Minus p dot. Minus minus p dot. So in this case, if you derive uh, the Hamiltonian with respect to p, what will you get? Na ako'y i-derive na ko siya with respect to t, I will get, napa by 2? Yeah, napa 2. So I will get partial h with respect to p, that is equal to 1 over 2m. Okay? Equal to x dot. And the other one, if I derive partial h with respect to x, I will get kx. Okay? I will get kx. Sakto? Partial h with respect to x, that would be 2 times 1 half is 1. So now kx equal to minus p dot. Okay. And then, wala na may 2. Okay, so, yeah. So I have minus p dot is equal to kx. And I also have, no, sorry. This is not only a p, no? This is a p lang, but p square. Sakto? This is p square. That's why na 2. Ano na 2? Anong na 2? Wala dapat 2, no? So, nako, mx dot quantity square that is equal to p square. Okay? So, this is actually not p over 2m, but p square over 2m. Okay? That's p square over 2m. So, therefore, if I derive it with respect to p, momentum p, what will you get is only 1 over m lang. Sakto? So, nako 1 over m lang. Okay? So, 1 over m. Okay? So, therefore, the mx dot, okay, the mx dot is just equal to uh, the mx dot here, 1 is equal to mx dot. Sakto, if you, so, sorry. This is p, okay? Sakto, because partial derivative of h with respect to momentum na ako'y 2p over 2m, so that's equal to p over m. Okay, so therefore, the momentum, so again, so ito one, no? The momentum is equal to mx double dot. Okay, and then if you do if you derive this one, p dot, it becomes mx double dot. Sakto? So if I derive p dot, if I derive the p, it becomes mx double dot. And comparing the two, compare na ko ng duha, okay, I will get kx equal to negative mx double dot. Okay, so therefore, mx double dot plus kx is just equal to 0, which is the equation of motion for harmonic oscillator. Okay, so this will be your answer using the Hamilton's equation of harmonic oscillator, using the Hamilton's canonical equation of motion. Okay, so ang inyo lang timanan is first is you need to express h in terms of v and in terms of x, and then after that derive, use two Hamilton's equation of motion. This one, okay, partial h with respect to p is x dot, and partial h with respect to x is minus p dot. Okay, Let's now answer katong ato ang assignment, no? Itong assignment nato na another example. Kanino? If you remember, in your assignment, I have this system na ako'y particle, na ako'y bead, which is moving paana, no? Paana nga motion. Okay, so this is your particle with mass m, and then it is constrained with uh, it is constrained to move along a smooth helix wire without friction under the influence of gravity. So ang yang mahitabo is ang yang motion is palibot pero padulong sa ubos because of the gravity. Okay? We know the Lagrangian of this. Okay? We know the Lagrangian of this. I have, I think, 3 kinetic energies and then 1 potential energy. So the Lagrangian is equal to 1 half m r dot square, duha ka translational ug isa ka rotational, plus z dot square minus mgz. No? We know this one. And then in your assignment, we solve for the lambda 1 and lambda 2. No? So let's solve that one. I think nakapasa naman siguro tatanan sa assignment. Solve na to itong lambda 1 and lambda 2, no? Check sa na ako ha kung nakapasa na ba ta sa atong assignment. Tanan. Ay, wala pa di no? Yes? Wala pa nakapasa. Sige. So, since ako na siyang answeran ron, so, kaning 9 nga na-assign, i-0 na ako ni. Okay? So, i-0 na ako ni diretso, no? 0. And then, let's answer this one. Okay? So, oops. Okay. Okay, let's answer this. What is the gamma? What is the lambda 1 and lambda 2? Okay. Okay, so we have this Lagrangian equal to that. Then we have these two forces of constraints, equation of constraints. Na ako'y kanino? Force of constraints. So na ako'y duha, no? Z is equal to K phi, and then R is equal to R. So in this case, I have F1 and F2, which is equal to Z minus K phi equal to 0, and then the other one is R minus R. Okay. So if I will write the corresponding Lagrangian with constraints na ako'y tulo, no? Because I have 3 general coordinates with respect to R, with respect to phi, and with respect to Z. Okay? So the first one is na ako'y partial L with respect to R minus d dt of partial L with respect to R dot plus duha ka bu constraints, so na ako'y lambda 1 partial F1. I think nasulat na ako ni last time, so di na ako nisulat, kanilang ako sulat, no? F2 and Fr. So I have 3 equations for this with respect to R, with respect to theta, and with respect to phi, and with respect to Z. So from that, if you do derivatives, you will get 3 equations. So the 3 equations are mr phi dot square minus mr double dot plus lambda 2 equal to 0. That the second equation would be mr squared phi double dot plus 2m r dot phi dot plus lambda 1k equal to 0. Okay? So, this is with respect to phi. Ang first equation will be with respect, derived with respect to r. The second equation will be derived mo siya with respect to phi. So, mr squared to mr k. And then, the last one would be, oops, last one. If I use Lagrangian with respect to z, this is now the third equation. We have mg plus mz double dot minus lambda 1 equal to 0. Okay? So, ang goal na to is to calculate or to determine what is the expression of my lambda 1 and my lambda 2. No? Using these three equations. Okay? Mg plus mz. Using these 3 equations and using the equation of constraints. Okay, we know the equation of constraints since z is equal to k phi. Okay, and from that we know that phi is equal to z over k. Okay, and if you derive this, you will get phi dot equal to z dot over k, and then phi double dot, that's equal to z double dot over k. Okay, k is just a constant. Okay, and from the second first equation of constraint na ko'y r over r, r equals r, ikan ana makakuha kag r dot equal to r double dot, which is just equal to 0. Okay, because take note, r is constant. Okay, because r is constant. So what will happen to these three equations? Okay, what will happen to these three equations? Na ay mga zero dira, no? Like kaning for the second equation, kani becomes 0. Okay, kani siya become 0. Kani mahimo siyang 0. Okay, then murag kani mahimo siyang 0. Sakto. Okay, mahimo siyang 0. So equation 1 becomes equations will be reduced to equation 1, mahimo siyang mr phi dot square. Mawala ang minus mr dot. Okay, so ma-0 ang mr dot. So na ako plus lambda 2 equal to 0. And I know that phi dot, ikan ani, phi dot is equal to z dot over k. So mahimo siyang ingani m r. R is now equal to big letter r. Okay, z dot over k quantity square plus the lambda 2 equal to 0. So now from that, masolve na ko si lambda 2, no? Di pa na ako masolve si lambda 2 kaya na po z dot, but na ako equation ni ngani m r z dot square over k square plus lambda 2 equal to 0. Okay, so I will put a box here. I will call this one as equation 1. Okay, equation 1, 2, 3, equation 4. Okay, equation 4. So, hapit na, no? Hapit na to masolve si lambda 2. Gamay na lang. Once masolve na ko si z dot, then makasolve na ko si lambda 2 na dahil in terms of m, r, k, and the z, and the g, no? And the g. The second equation becomes, mawala ang second term, so mahimo siya ingani, no? Nakoy m, r square, z, double dot, m, r square, z double dot, over k. Sakto? Because, take note, the phi double dot kani siya the phi double dot is just equal to z double dot over k. Okay, so ang akong gibuhat is gi-express na ko tanan in terms of z, no, using the equation of constraints. Express na ko tanang equations kani kay three variables man eh. So right after the Lagrange equation with constraints, ako ang gi-incorporate ang duha ka equation of constraints para ma-reduce ang akong variable from r, phi, and z into one variable, which is I choose z nga mabilin sa akong equations. Okay, so i-express na ko siya in terms of z tanan, no? So na ko mr square z double dot plus lambda 1 k equal to 0. So I will call this one as equation number 5. Equation number 5. Okay. And for the last one, the last equation will be reduced to this. The third equation will be reduced into mg plus mz double dot minus lambda 1 equal to 0. Okay. So this is my equation number 6. Okay. If I use equation number 5 and equation 6, okay, using combine equation 5 and 6 to solve for lambda. Okay, to solve for lambda 1. So if I use equation 6 and equation 5, yan 5 ni siya, no? 5. Okay, if I use equation 6 and equation 5, makakuha ko og lambda gikan nato, no, using substitution method. makakuha ko lambda 1 equal to mg plus mz double dot. Okay? Again, makakuha ko kaninga form. Okay? Again, if I combine equation 5 and equation ano, di mo. Di pa na mo, no? Gikan pa ni siya sa equation number 4, number 5, sorry, number 5. If I solve for lambda 1 there, makakuha ako og lambda is equal to mg plus mz double dot. Mag-cancel out ang k. Ano mag-cancel out ang k? Dili dapat mag-cancel out. From equation lambda k c asa 2, 3 yung equation 3. Oh, ano mag-cancel out sa? Hindi sa dapat. M R K ano dito? Sa yeah, this is for equation 3. Sorry. Oh, kanilang din nasa, no? I just transpose the lambda 1 there. If I transpose the lambda 1 there, makakuha ko yung ana, and then I will substitute this one to equation 5. Sub to equation 5. What I will get is this. Equation 5 is given by this. M R square Z double dot over K plus this, the lambda 1. Okay? Mz double dot times K. And in this case, you can solve for Z dot, Z double dot. That will be your equation of motion along Z. So from this, oops, you can solve for Z, solve for Z double dot, solve for Z double dot. Ako ang makuha, gikan no, di na ako ikuha ng steps, but from this, I can solve for Z double dot, and that will be your final equation of motion along Z, which is equal to minus g k square r square plus k square. Okay, so if you simplify this further, you will get minus g 1 plus r over k square raised to the power of negative 1. So this will be as you can see here, this will be the equation of motion along Z. No? Minus g 1 plus r over k quantity square raised to the power of negative 1. And after that, nasolve na ko sa equation of motion along Z. Equation of motion in the Z direction along Z. Sa Z, okay? I can solve now for lambda 1 because I know that lambda 1 from here is equal to mg plus mz double dot. Therefore, lambda 1, this will be your final answer for lambda 1. Therefore, lambda 1 is equal to mg plus mz double dot plus mz double dot equal to mg minus mg over 1 plus r over k quantity square. So this will be my lambda 1. Okay? So nakuha na ako si lambda 1. mg over 1 plus r over k quantity square. Okay? So this will be my lambda 1. How about for lambda 2? Lambda 2 from equation number from equation number 4, lambda 2 is given by this. Lambda 2 is given by minus m r z dot square, okay? Not z double dot, but z dot square over k square. So what we need is, we need first to solve the z dot, no? How are we going to solve for the z dot? Take note that z double dot, we know z double dot, nakuha na to ni equation of motion ni z, it is equal to minus g, okay? Minus g 1 plus r over k square to the negative 1. So therefore, if you solving for z dot, dali lang, no? If you have z double dot, that is just equal to dz dot over dt. So ang imong buhaton is um, you just need to integrate, no? Integrate na ko ni, no? 1 plus. Take note, sayon naman siya kay constant naman ni siya, no? So therefore, the z dot here is just the integral of minus g 1 plus r over k square raised to the power of negative 1 dt. And take note, g, r, k are constants. So you can factor that out to the integral. So i-factor out na ako daan sa integral, no? So, factor out ko na. Sana ko dira. Okay? This is from 0 to t. From 0 to t time. So therefore, the z dot is just equal to minus gt 1 plus r over k squared raised to the power of negative 1 t. Nanay t dire, no? Nanay t. And if you do the z dot square, because take note lambda 2 is equal to z dot in terms of it is a function of z dot square, not z dot only. So the z dot square is equal to g squared t squared 1 plus r over k squared raised to the power of negative 2. So that your lambda 2 is just equal to minus mr over k squared times g squared t squared 1 plus r over k squared raised to the power of negative 2. So this will be my lambda 2. Okay? So, kana lang, no? So, nakoy lambda 1 and the lambda 2 there. Okay? So, that will be your, that was your assignment. Okay? So, that was your assignment. Solving for lambda 1 and lambda 2. So, now, instead of using Lagrangian, I will use Hamilton's. I will use Hamiltonian to derive, okay, next is using, so dinanin mo yung assignment, no? Using Hamilton's equation of motion, using Hamilton's equation of motion, we will derive, i-check na to kung pares ba sila answer, no? This one, z double dot, which is equal to minus g 1 plus r over k quantity square raised to the power of negative 1. So let's check whether our equation of motion along z is equal to this one using another method, which is this Hamilton's equation of motion. Tulo man actually, no? You need to solve, but in this case, in my example, I will just answer the z double dot. So naput tayo makuha nga phi double dot and r double dot there. But I think r double dot is just equal to 0. So wala kay makuha or wala kay makita nga equation of motion sa r, because take note r double dot based from here itong sa equation of constraints, no, the r double dot is equal to 0 and the phi double dot is just z double dot over k. So ang imong buhaton nanong po z double dot, no, so makuha na ko ang phi double dot. Okay, makuha na ko ang phi double dot just by dividing it by k, no? So, r double dot is 0, and then phi double dot is just equal to z double dot over k. So, this is just equal to minus g over k times 1 plus r over k quantity square raised to the power of negative 1. Okay? So, ang pinaka-importante is kaning z double dot, no? Once you know the z double dot, you will get the phi double dot, and of course, r double dot is just equal to 0. Okay? So, again, using Hamilton's equation, what will be the equation of motion with respect to z? Okay, so what will be the z double dot? Okay, if you have time to solve, you can also solve for the Hamilton's equation of motion with respect to phi. Okay, so with respect to phi. So kani in z lang, na ako'y duha ka equation of motion, na ako'y Hamilton's equation, na ako'y partial h with respect to pz, okay, which is equal to partial h with respect to pz is equal to z dot and partial h with respect to z is equal to negative p z z dot. Okay, negative p z dot. Negative. Okay, yeah, negative p z dot. Okay, so if mukha sa phi, dali lang po, no? Na ko partial h with respect to p phi equal to phi dot, and partial h with respect to phi is equal to negative p phi dot. Okay? So, ang ato lang buhaton mo is only this one, only the z. Okay, only the z part. So, what will you do is first you have to express the Lagrangian in terms of into Hamiltonian function, no? So, I know that the Lagrangian so ito atong first step is express first the h as a function of momentum and the position. Okay? So, express first PZ, H in terms of PZ and Z. Okay? Gikan sa Lagrangian, Lagrangian is just equal to this, no? 1 half m r dot square plus r square phi dot square plus z dot square minus mgc. Okay? And then, I think ma-reduce din mo ni siya if I use since z is equal to k phi, r is equal to r, balik na ako, no? Phi is equal to z over k, then phi dot is equal to, I think, z dot over k, and then phi double dot is z double dot over k. So, gamito na ako ng mga um, equation of constraints. Ma-reduce na ito ng Lagrangian into one single variable in terms of z na lang, which is just equal to 1 half m of 1 plus r square over k square z dot square minus mgz. Okay? So, gamit aning equation of constraints, okay? Gamit aning equation of constraints, we can reduce the Lagrangian into that one. Okay? So, in terms of z na lang, no? In terms of z na lang. So, therefore, the Hamiltonian is just equal to this. Okay? Gamay na lang ha. Kadot lang. Pwede ra makakonta gamay. Mga 5 to 10 minutes. Okay? So, I can express the Hamiltonian into this 1 half m 1 plus r square over k square z dot square minus m plus mgz. Okay, what will you do next is you have to express pz, no? You have to express Hamiltonian in terms of pz and z, no? So na technique how to do this one, how to transform with respect to z dot into pz. Okay, kani kay wala di pa ni mao, no? Dapat express nato ni siya in terms of pz, no? In terms of pz dot. Okay, so na technique how to do that, we know that pz is just equal to partial L with respect to z dot. So from that from this I can solve for pz equal to mz dot 1 plus r square over k square. Okay, so if I derive L with respect to z dot, makakuha kong pz nga equal to ingani. So therefore, the Hamiltonian, you can express Hamiltonian as this. The pz is equal to that. So Hamiltonian becomes, this is in terms of momentum and position. Momentum and position. The Hamiltonian can be expressed into this. pz square over 2m times 1 plus r square over k square plus mg times z. Okay, so this will be our Hamiltonian. And then do the Hamilton's equation of motion. We have partial h with respect to pz. This is just equal to z dot, and from that makakuha ako nga nga form z dot is equal to pz. If I derive the Hamiltonian, no? If I derive the Hamiltonian with respect to pz, na ko pz m1 r square over k square. Okay, so this is my z dot, and the other one, partial h with respect to z dot z partial h with respect to z, this is equal to minus pz dot. So, from that, makuha na ko nga si pz dot is equal to minus m times g. Okay? Minus m times g. And then, the sorry, the pg double dot, okay? Pg dot is just equal to minus pz, okay? So, therefore, uh, uh, as you can see, the p dot is just can be expressed as dp dt, no? So, therefore, the d dt of my pz is just equal to minus mg, and we know pz here. Okay, from that, pz is equal to this pz is equal to, since pz is equal to this one, the mz double mz dot 1 plus r square over k square. If you derive that one, okay, if I derive that, so na ako'y d dt of mz dot 1 plus r square over k square equal to minus mg. So we have mz double dot 1 plus r square over k square. Take note, m, r, k are constants. Minus mg. From that, you can cancel out the m. Solving for z dot, that's equal to minus g over 1 plus r square over k square, which is just equal to minus g 1 plus r over k square raised to the power of negative 1. And this is, as you can see, same exact or parehas ko ang answer for z double dot using Hamilton's equation of motion and using the Euler-Lagrange equation. Okay? Using the Euler-Lagrange equation. Sakto ba? Nakoy z double dot kanino? Kung nantawin mo nakoy z double dot equal to that, so para sa siya ni ato ang using Hamilton's equation, para sa siya ni atong anak ko nga answer. Okay? And that's it. That's it. This will be our last topic. So